So, greetings and a warm welcome to all the distinguished participants joining us from different corners of India and across the globe for the first edition of PowerUp EV, a series of virtual business meet on EV technology, battery manufacturing, and charging infrastructure that Smart Energy Magazine has scheduled for the year 24-25. It's truly a pleasure to connect with such a diverse and dynamic audience, showcasing the unique beauty of virtual events, the ability to connect locally and globally simultaneously. Today's gathering is a testament to the success of our webinar series in 2023, where we witnessed engaging discussions led by industry renowned speakers and attended by professionals, leaders, and key decision makers. These sessions delve deep into the various aspects of EV sector, addressing key challenges while also highlighting new business opportunities. The current growth trajectory of EV sector, supported by favorable policies and government initiatives promoting clean and environmentally friendly transportation, has created numerous untapped opportunities for businesses. PowerUp EV platform aims to bring together stakeholders from across the EV sector to explore these opportunities, initiate discussions of key topics, and address key challenges faced by the industry. As we embark on today's business meet, we have curated a lineup of stellar discussions on various topics that will be shared by our esteemed speakers, providing invaluable insight into the EV landscape. I extend a heartfelt welcome to all our speakers and express our gratitude for their participation. I would also like to extend our sincere appreciation to our sponsors, Hyperion Chargers Private Limited, Comsol Multiphysics, Gantner Instruments India Private Limited, and EV FinServe for their unwavering support. Your trust in us has made this event possible, and we look forward to your continued support in the future. Special mention must be made of the Indian Energy Storage Alliance and India Electric Mobility Council for their support in organizing this series of virtual business meets. Before we dive into the discussion, it is my great pleasure to welcome Dr. Dev Mukherjee, who has graciously agreed to inaugurate this event and deliver the keynote address, setting the tone for our discussions. Thank you, Dr. Mukherjee, for honoring us with your presence. Let us seize this opportunity to collaborate, learn, and innovate as we navigate the exciting landscape of electric mobility. Thank you all for being a part of this event. I would now request Mr. Mukherjee to take over and deliver the keynote address and set the tone for this event.
Yeah, thank you very much, Santosh. It's always a pleasure connecting with the fellow professionals in the industry, and I'm honored to be part of it. And thank you very much for your kind remarks introducing me. As I delve into this topic of alternate energy, electrification, electric vehicles, and the whole ecosystem consisting of vehicles, then the supply chain, powertrains, motors, batteries, and the whole battery ecosystem in itself. I look at this, change that is happening, this significant and very profound change that is happening in India, and I see that India is in transition. India is transiting mainly in the energy space from fossil fuel to renewables, and in that, obviously today battery is the mature technology, and some other technologies which are on the the S curve growing very fast toward maturation are hydrogen and some alternate hybrid technologies. So I think this transition is very, very significant because it has it is happening at a great speed, and secondly it is happening at a very big scale. In India we are not used to having both together. Generally, either we have speed but not scale, means the change happens in a small pockets, or we can have scale but it happens at its own pace, takes time, etc. This is how most of the changes in India have happened in the past, but this time I'm seeing this transition to clean energy transformation is happening, in both speed as well as scale. Part of the driver or a large, the driver of this is the government resolve to have the achieve the targets which have been already documented and published, that India would like to have 50% renewable by 2030 and 100% zero emission carbon neutral country by 2070. So I see that this whole electrification, the clean energy transition in this direction. Now, to my if I analyze the whole spectrum, I see that this clean energy transition is happening in two broad spheres. One is the industry, wherein the industry is shifting to clean energy, and it will happen more and more with the ESS, battery storage, etc. coming in batteries. Then the other technologies like hydrogen, ammonia as a carrier, etc. will happen. So energy consumption by the industry is huge. And second sphere is the mobility, wherein I can comfortably and I think proudly say that India has been a success story as far as electric vehicle transition is concerned. Last year we did close to 2 million vehicles, 1.8 million. Out of that, two-wheelers and three-wheelers are the real success stories, wherein two-wheelers were about 1.5 million vehicles, and 500,000 plus were the three-wheelers. So these two form factors have actually driven the battery movement in India. And I think that the next disruption which is waiting to happen, and it will happen, and this financial year we will see a lot of this happening, is going to be the trucks, particularly led by the pickup truck segment, which is a very large segment in India, dominated by brands like Tata Ace, etc. So in mobility, I think the roadmap is quite clear. My personal opinion is that the inflection point has been breached in the the S curve of development in this space, in the mobility space, wherein we have in three-wheelers, for example, in the e-rickshaw segment, more than 50% of the vehicles are electric, and in two-wheelers also we are close to about 7%. So I think this financial year probably we will have 2 million scooters and maybe more than 500,000 etc. the three-wheelers, and then there will be buses as well as the trucks, as I said. So I think clean mobility is very much taking place in India. That is a very big transition that is happening. Now, coming to what does this entail? What it entails is when you talk about the automotive industry. Automotive industry is a very material intensive industry, wherein the supply chain plays a huge role in success of an industry. And this being a highly material intensive industry, a lot of material movement happens, and the OEMs typically put together all the parts and materials and technologies, and then the finished vehicle gets rolled out. So in this space, I think while the government has pushed on the demand incentivization by FAME scheme, etc. On the supply side, we have some PLI, etc. But I think a lot of work needs to be done on the supply side. Putting the links of these supply chain together is going to be very, very important to achieve what the government and Niti Aayog, etc., are saying, and they have the ambition to reach about 30% of electric by 2030. So that's a huge number, given the fact that we make almost 20 million scooters and 1 million three-wheelers, and then 4 million plus cars. Probably will be around 6 million cars by then. So if you take across the board 30%, so these are going to be very, very big. So the only way this kind of transition will be successful in these numbers are only if we have the supply chain in place. And this is where the MSMEs, who play a major role in the industry or the manufacturing economy of India, they are going to play a major role. They have their own challenges of investment and access to capital, etc. But all those have to be handled. And this is where I think government needs to come up with more incentivization of the supply side. Um, so that's where a lot of effort needs to be made. And the battery itself is going to be a large portion of this supply chain, wherein today if you compute the broadly the capacity, we are already around 20 gigawatt hours. Okay, so and by 2030, if we continue on this, we will definitely need more than 200 gigawatt hours. That is what Niti also projects. So going from 0 to 200 in about 5 years is going to be a huge challenge. So I'm talking about cell manufacturing. Even battery pack manufacturing is also not very stabilized as on today. Battery pack, then BMS, etc. So this whole battery economy itself will have to be set in place, where it starts with kind of cradle to grave, as we call them: cell manufacturing, pack manufacturing, BMS integration, then going into the charging, and then end of life treatment of the battery, used batteries. So that is how the whole battery economy will emerge in the country. And OEMs are going to play a major role, because this is the first time OEMs are responsible for fuel of the vehicle. And this is a huge mindset change that OEMs are also trying to figure out how to sort of put this strategy in place. So I think next out, other than the battery, would be the charging the space, where again the success of the EV will largely depend on how accessible is the charging, how widespread is the charging. Global norms are 1 in 20, one charger for 20 vehicles. Today I think we are one charger for maybe 200 vehicles or whatever. So I think we have a long way to go in there. In that, the technologies of rapid charging, fast charging, even swapping will play a role. And a lot of these in the small power, small form factors happen in home, as we know, scooters and several three wheelers as well. So this is where the whole infrastructure of charging has to be put into place in large numbers. By a broad estimation, if we talk about 30% conversion, then India will need close to about, I think, 2.5 million charging stations. Today we are just about 5,000, and I'm not sure if all 5,000 are operational. So the whole accessibility to charging is going to be a key factor for the success of electric vehicles. So um and let's talk about the the opportunities here. Um if I sort of summarize the opportunities in this whole space of renewable energy in mobility, industry, and then eventually maybe home and retail side also, the opportunities are going to be: one is the technology opportunity, wherein the industry can either develop their own technologies which are suitable for India, or have access to them from anywhere in the world. So that technology opportunity comes to India, which can be become a global opportunity, not only for India, but a huge global opportunity for batteries, cells, motors, power electronics, etc. So I see that a very big opportunity for Indian industry to become a global industry, which somehow did not happen during the IC era. We were a largely domestic driven industry. Second opportunity is the economic opportunity. As per a KPMG report, India needs about 300 to 400 billion dollars to achieve the renewable targets. So this is a huge amount of money which will be spent on these technologies, whether it is battery, BSS, charging, hydrogen, and some other technologies. So a lot of this money would be put in by investors who see this as an emerging and viable asset class. So this is where I think the industry needs to invest, because the ROIs will be over a longer period of time. Third would be a socio economic opportunity, where I believe that a deep penetration of EV can lift a large number of people out of their poverty, particularly in the rural areas. Electric vehicles can become a source of income generation in sectors like agriculture, healthcare, etc., wherein these vehicles can provide a cheaper alternative to fuel vehicles. and then obviously as the income grows, the people life style and improves and increases, and this has a very large multiplying factor according to me. So as an economist, I can say that the implication of electric vehicle on a deep rooted scale is very very big. And obviously, fourth and the last, according to me, the opportunity is the environmental impact opportunity. See, environmental concerns are not a hoax. Many people, would like to believe that there is no environment impact and life goes on as usual. But we are seeing in our own country, we are seeing floods, flash floods. We are seeing extensive heat. We are, city like Bangalore is facing tremendous pressure. So because of rapid urbanization and all these carbon emission, etc. So this is a serious threat, and again, it has a very very deep and impact on the population. So this is where I think the opportunities lie in this transition, and we can really make a big difference to our country. And if I personally believe that if India has to march on this ambition of 10 trillion to more about 20-30 trillion economy, then energy is going to be a major driver, and it will play a very big role in this. So this is where the India's opportunity lies to develop this new alternate technologies of energy. So these are my thoughts, and it would be wonderful to hear your participants and their views and their thoughts, and I'm looking forward to it. So thank you very much for having me. It's a pleasure to be in this event. Thanks a lot.
Thanks a lot for this wonderful uh, keynote address, actually, that has set the tone for our event that is there. As you have rightly said, that the opportunity in the EV space are coming both at speed and scale. Definitely, you have touched upon a lot of important topics: the role of MSMEs, their challenges, government incentives, importance of battery change, and the role of OEMs that will play in the future of this EV industry. Rightly, as you have mentioned, success will depend on charging stations also. There is also an immense opportunity over there. Technology opportunities, economic opportunities, socio-economic opportunity. I guess we are seeing a lot of uh, news on this front, actually, where EV is playing a major role. Environmental impact, definitely all of are concerned, and you have rightly mentioned on that. So thanks a lot for this keynote address, and uh, setting the tone for uh, the today's actually meet and the series of meet that we are going to schedule or arrange in the near future. So just now we heard about our keynote address that was delivered by Dr. Dev Mukherjee. He's currently a chief advisor to the chairman at Angelian Omega Group. I once again thank Mr. Mukherjee for coming and delivering this keynote address.
Thank you very much. It was a pleasure, Santosh, and all the best for your further events. Thank you.
So we will move on with our first session that is going to be addressed by Mr. Rajaram TR. Mr. Rajaram TR is the current head of Gantner Instruments India operations, overseeing its Indian subsidiary, Gantner Instruments India Private Limited. With over 18 years of experience in the field, Rajaram specializes in providing test and measurement solutions for various sectors, including automotive, aerospace, transport, energy, and civil industries in India. He has been actively collaborating with electric vehicle manufacturers, offering high-speed data acquisition systems for measuring electrical, mechanical, and thermal parameters during the testing of batteries, inverters, and electric motors. Rajaram's expertise and extensive industry knowledge makes him a key player in advancing test and measurement technologies for EVs and other critical sectors, contributing significantly to the growth and development of the Indian industry. Today, he is going to delve deeper, and his topic of discussion is Gantner Instruments High Speed DAQ for EV testing. I welcome Mr. Rajaram for this session and would request him to take take further from here.
Thank you, Santosh, and thank you for giving us this opportunity to interact with all the fellow panelists as well as the participants of this webinar with respect to data acquisition system for battery testing. So I'll try to keep it as short as possible and within the time frame what is allotted to me. Uh, so uh, we basically, Gartner Instruments are basically a test and measurement company providing high speed, high resolution data acquisition systems for testing of almost all the three critical components in the EV's ecosystem, namely the battery, the inverter, and the motor. So we are basically a company which based out of Austria, and we have been present in India from 2008 onwards, catering to the automotive industry, both conventional as well as the EV industry. So when you talk about data acquisition on EV, whether it can be a battery, an inverter, or motor, as a manufacturer of any of these components, you really want to test and validate these products before you put it into the real-time environment. And that is where the importance of data acquisition, or getting the data, electrical, mechanical, and thermal data with respect to these components comes into play, and the importance of high resolution and high speed measurements comes into play. If you typically consider the EV ecosystem, some of the basic test or some of the critical test what you want to do is basically the electric motor dynamometer testing, the chassis testing of the vehicle, battery testing, inverter testing, the hydrogen powertrain, fuel cell, any kind of testing. All these requires data. The manufacturer requires data at a very high speed to validate the performance, the efficiency of the component that he or she is manufacturing. And today, as per the topic, we will really concentrate on battery testing, how critical is to get data out of the battery when you manufacture the battery and in real-time environment. So if you see a battery, what are all the parameters you are really interested to measure? I have listed out the main parameters or the critical parameters what you should basically measure on a battery. That is, you have low voltage and high voltages, low currents and high currents, temperature, strain gauge measurements, vibration measurements, and your power measurements. So these parameters are very important, and as a manufacturer or doing the testing and validation of the battery, you should have a high-speed data acquisition system which is capable of measuring all these critical parameters, so that you, as I told earlier, you understand the product, what you are making is efficient, it delivers as per the standards, it delivers as per the safety norms which is prescribed. So measurement of all these parameters at a very high speed becomes very critical. So now diving deep into battery testing. So you can use our data acquisition systems for various kinds of testing applications on battery. It can be on battery test beds, it can be on vehicle or on board measurements on the vehicle, or it can be on battery research labs where the manufacturers are interested in getting high resolution, high speed data to validate all kinds of parameters with respect to the battery. In Gartner, we always believe in giving complete modularity, flexibility, and scalability to the systems what we provide. So keeping those ethos and philosophy in mind, we have different series of data acquisition systems available for different kinds of testing on batteries. And on a battery test bed, it can be a DIN rail mountable modules where you connect all the sensors to this DIN rail mountable systems and you do the measurement. For onboard or portable applications, you have a IP rated system which is tested for shock and vibration, which you can put on a vehicle itself and do the measurements. On for battery labs, where you do a lot of R&Ds with very high channel count, you can have 19-inch 3U racks. So the complete system is modular, flexible, scalable, and it's also completely open with related to integration with third-party evaluation systems. So that is what makes us successful globally as well as in India, cooperating with a lot of manufacturers of batteries. One of the important things when you are doing the testing of the battery, one of the important things on or technical capability or technical feature that you should look for is basically high galvanic isolations, because when we are moving from the conventional measurement that is in the ICE automotive or a conventional automotive application, in batteries as well as in motors as well as in inverters, we are really talking about high voltage and high current, and we need to have very fast sampling. That is, sampling is nothing but the number of measurements per second. So each parameters has to be measured at a very high speed simultaneously. Time stamped real-time measurement has to be there. So for doing that, it is very critical that we consider the feature of galvanic isolations. So in a real-time testing environment, you have other devices running in the factory, you have other sensors working, you have crosstalk coming or noises coming from different fields. So you have to have very high galvanic isolations in your data acquisition system to completely nullify all these external parameters like EMC, crosstalk between channels, harmonics, etc., and to exactly measure what you require from the sensors. To do that, we have come up with a complete three-way isolation of up to 1500 volt DC. By again, this three-way isolation is channel to channel, channel to supply, and channel to bus. That means that your complete measurement chain is isolated, and you exactly measure what you get from the field sensors as part of your testing of the batteries. We also have to have, so if you see the conventional testing application or conventional data acquisition or legacy systems, what has been in the market, so everything you used to have a centralized data acquisition system. You have to run all the cables from this test lab, from the testing test bed to the centralized DAQ. That means lot of cabling, lot of space consumption. It's not flexible. So now as the EV technology or the testing technology is evolving, we see most people going towards a distributed architecture. So as you can see in this slide, you have an electric vehicle under test inside a test bed. So we completely support a distributed architecture. So we distribute our IO modules, which gets connected to the sensors in the test bed itself, very near to the sensors. We do the analog to digital conversions at a very high resolution of 24-bit and with the sampling of megahertz or kilohertz based on the customer requirement. And then everything comes to a centralized controller where we do the timestamp of measurements, and from the controller we put it into any host level software. So as you can see in this slide, the controller what we supply, it supports all communication protocol, because as you know, the EV technology is evolving. You have different analytical softwares coming in for analysis of the data which you take from the data acquisition system. So in that way, we have kept it really open. So our hardware, the data acquisition hardwares what we give are really open, and we support almost all industrial protocols or communication protocols available in the market, so that third-party integration to OEM systems as well as end user systems becomes pretty easy. So now if you really see what you test on a battery or what you measure on a battery, you can really split up the battery pack into cell level, the module level, and the pack level. So when you talk about cell level, you are interested in measurement of voltage, current, and temperature, which comes across each cell in a battery pack. So for doing that, you don't require a very high isolated module to do that, because in a cell level, typically each cell produces around 3.8 or 4 volt of voltage. So you don't require the 1500 volt isolated data acquisition system to do that. So for that, we have modules with standard 500 volt DC isolation, through which you can measure cell voltage, cell current, and cell temperature. So that's on the cell level. And if you are considering an array of cells, which we call it as a module, an array of cell will produce a voltage in the range of around 60 volt. So again, here also you don't require a 1500 volts system to do that. So with our 500 volt DC galvanically isolated modules, we are able to measure voltages up to 60 volt and currents through a CT or a resistor. We can do that. And now when we come to the complete battery pack level, this is where typically or classic high voltage and high current measurement comes in the range of 400 to 1200 volts. So for that, we have a special series of products with 1500 volt DC galvanic isolation, wherein you can directly connect the high voltage as well as high current and temperature measurement with high isolation. So the measurements on a battery can be broadly classified as cell level measurements, module level measurement, and pack level measurement. And we cover the whole spectrum of measurements with our modules with respect to battery testing with going by this architecture. Here you see in this slide, you can see a battery pack under test. So whatever we discussed in the last slide, this is the real-time example of that. So you have a battery pack under testing here. And in the battery pack, the customer is or the manufacturer is interested in cell voltages. He is interested in the temperature stability. That means he uses an RTD or a thermocouple to do the temperature measurements. He is also interested in the structural stability of the battery pack. So he does different kinds of tests to make sure that the battery pack remain intact. The structural stability of the battery pack is intact in case of vibrations, in case of a fall or something like that. So we have strain gauges to do the structural measurement. He is also interested that with respect to temperature, there should not be any deformity of the battery pack. So we have IP cameras integrated so that as part of testing, so that he really sees if there is any deformity of the battery pack with respect to change in temperature, etc., etc. So all this can be done in a single data acquisition system from us. So we have voltage measurements, current measurements, strain gauge measurements, vibration measurements integrated to IP cameras. And we also have our controllers also have CAN connectivity. So most of the battery management systems available in the market comes with CAN connectivity. So we can also interface our controllers with handshake, our controllers with the internal BMS system of the battery pack, and monitor that everything is within limits as part of the testing or within tolerance levels of the specifications put for the battery pack. And we get a complete analysis with respect to the health of the battery. Another thing with respect to testing of the battery, another interesting topic which is very hot currently in Europe as well as in US with respect to battery is measuring the impedance levels inside the battery pack. So we can also do that. We have special modules to do the impedance spectroscopy. We have a separate system to do that. So we can also, by measuring the impedance, we can also monitor and control the degradation of the cells during frequent cycling, means charging and discharging. So we can know the kinetic process, what is happening inside the battery with respect to different time domains, with respect to charging and discharging. And we can also completely predict the health of the battery by doing the impedance measurement. So some real-time application examples for you. This is basically onboard measurements on a vehicle. So the customer here is interested in really understanding the battery voltage, the battery current, and real calculation of power as part of benchmarking of the batteries which they are manufacturing. So as you can see in this slide, we are directly measuring the high voltage and high current to our DAQ system, and we are doing the complete power calculations, and we are doing the complete analysis, everything at real time at a very high resolution and at a very high sampling speed. Another example of another interesting topic with respect to battery is power analysis. So we have also come up with a special series of ranges of power analyzers with a very low noise floor ratio, which is very critical for accurate power analysis and decision making. So we have megahertz sampling in this and a very low noise floor ratio. And we can do the complete power analysis of the battery pack with this separate power analyzer module from our end. And everything is, as I told you, time-stamped real measurements. To support our customers, even though predominantly we are a hardware company and our specialty remains in providing rugged measurement modules as part of EV testing, we also have come up with our own software, which we call it as GI Bench. Again, most of the features required for analysis as well as real-time visualization are embedded into this software. So this is provided along with our systems to the customer, so that he can do real-time measurements, real-time monitoring, and post-test analysis. So the slide, as you can see here, here the customer is in this current slide, the screen, the GI bench screen, what you see here, the customer is measuring high voltage and high current at a very high sampling, and he is calculating the instantaneous power, the apparent power, and the real power with respect to the subject under test. So we can do, these dashboards are completely programmable. It is completely customizable. So the customer can do whatever he wants with respect to the type of reports or the GUIs, whatever he wants in the software. So some of the common tests, what you see in the Indian industry or in the battery industry, you have different kinds. As a manufacturer of a battery, you do different kinds of tests on a battery pack. So it can be the charging and discharging test of your battery. You periodically charge many times, so many cycles of charging and discharging to see the deterioration or how effective is the charging and discharge happens on the battery pack. That needs measurements at a very high speed. You have safety or abuse testing, where you need, for example, you abuse the battery to harsh environments as well as environmental conditions, and see how the battery behaves or how the failure pattern of the battery is. You also do performance testing on the battery, where you determine the efficiency of the battery under different test conditions. Another important test what they do is the thermal stability test of the batteries. You see a lot of cases like the battery catching fire, which attracts a lot of social media attentions, unfortunately. Again, that calls the need for real-time measurements on the temperature stability of the pack which they are manufacturing. So it can be vibration, shock, EMC, thermal, dust, corrosion, humidity, all these of environmental and thermal testing of the battery pack is also important. So we support manufacturers by providing high-speed modules which can collect real-time data as part of all these tests. So I have mentioned only some tests, but they do a lot of tests on battery globally. At the end, so as a manufacturer of a battery, what are the things what you should basically look for when you are selecting a data acquisition system? I have put some bullet points which can go as you can consider while selecting a data acquisition system for your battery testing needs. So the DIAQ what you are going to buy or select should have the capability of connecting all kinds of sensors or which can mainly temperature, strain, torque, speed, power, high voltage, high current. So all these kinds of sensors should be connected to a data acquisition system. It should have that capability. Again, you are interested in real-time high resolution measurements. So always go with a system which has got a very high resolution and high speed that can be 100 kilohertz up to megahertz per channel. The criticality of the measurement will help you, or the data what you collect as part of the measurement will help you to make the battery pack better. So always go with a high galvanically isolated system of 1200 volts or 1500 volts. Has to be three-way so that you don't have any channel to channel or cross channel noises coming as part of your measurement. Always select a DAQ which is open. That means you don't go with a closed system. You should always have an open system which can be integrated to third-party OEM softwares as well as manufacturer and analysis software suites. You should also have a very high filter functionality which will help you to filter out noises, EMCs, harmonics, etc., which exist in a real-time testing field. So always have advanced filter functionality should be part of any high-end DAQ what you look for. And as the testing of the batteries or the testing of any of the component in the EV is completely evolving, we have new technologies coming up day by day. So modularity, scalability, and flexibility is pretty important, and that should be the backbone of selection for any DAQ system for your testing and evaluation need. At last, if you see the Gartner ecosystem, what we provide, so your testing requirement can be pretty simple here. You are doing some measurements on a battery pack and you are putting it into a local computer, logging all the data, taking a report out of this. So this can be your requirement today, but you should always think of the future. And by doing that, the system should be scalable to new technologies that is evolving day by day. So we have kept that in mind while we design the ecosystem for EV testing. So as I told you, your requirement today can be pretty simple, but tomorrow you should have the flexibility to adapt the same system to different needs, or number of channels being increased, number of measurement modules being increased, connectivity to different communication protocols, connectivity to different software suites for analysis, remote analysis or remote dashboards to evaluate a vehicle under test in the road, where you can see the real-time parameters of the battery of the vehicle sitting at your office. So remote monitoring becomes a point. You should also have cloud connectivity. We see most of the manufacturers investing a lot into their cloud architecture now. So the DAQ system should be capable of putting the data into the cloud. So Gartner pretty much covers most of these things, and that is why most of the EV manufacturer, it can be a battery or a motor or an inverter, or it can be a validation of the complete vehicle as a whole, prefers Gartner, so that we provide this flexibility and this much open system so that they can pretty much do whatever they want with the test and measurement system what we provide. So as I told you, we have been present in India for a long time now. From 2008 onwards, we have been collaborating with most of the manufacturers globally as well as in India. We were pretty much fast movers. Since being a global organization, we were pretty much ready with our portfolio for EV quite. So we always had the first mover advantage with respect to providing data acquisition systems for EV testing applications. And we are now extensively customizing our products, customizing our software, customizing our complete offerings to meet the demands of the Indian customer as a whole. So at last, our job, I will conclude with this slide. So our job as a test and measurement company is to provide you with accurate data or information with respect to critical parameters to evaluate your product. And obviously, when you have real-time, precise, high-resolution data, this really helps you to make your products better. Whether it may be a battery pack, it may be a motor, it may be an inverter, or it may be the electric vehicle as a whole. So that's our job, and we really look forward in collaborating with a lot of Indian OEMs as well as end users to help them with high accurate data as part of their testing and validation process. I stop with this, and thank you for your opportunity, Santosh, to have me here, and it was my pleasure to interact on this session. Thank you.
Thanks a lot, Mr. Rajaram, for coming on this for this virtual meet and sharing your insights. And as you have rightly said, that data is very important, and turning data into info and turning info to customer benefit. So that's I think the key takeaway that is there, and how Gantner is very helping uh, in data monitoring. So if there are any questions from the participants, they can ask before we move on to our next present session. So anyone has any questions to Mr. Rajaram? Okay, so we will move forward, and let us see if there are any questions that come up, then we can take it later on also. So our next uh, speaker is Mr. Sharad BN. He's a technology specialist at Comsol. Before I hand over to Mr. Sharad, a brief intro. He's a technology specialist at Comsol and he works at the Indian office of Comsol. Holds a master degree in machine design from BMS College of Engineering, Bengaluru. Prior to joining Comsol, he conducted mechanical integrity assessment of Siemens gas turbine and Tata Consultancy Services. His expertise lies in the application of technology to solve complex engineering problems. At Comsol, Sharad contributes his skill to advanced simulation software, enabling engineers to innovate and optimize design. His background in machine design and experience with gas turbines makes him a valuable asset in the field of engineering simulation. Through his work, Sharad continues to drive technological advancements and contribute to the evolution of engineering practices. Today, he is going to present on simulation-driven innovations in e-mobility using COMSOL multiphysics. I would request Mr. Sharad to take over from here.
So thank you, Mr. Santosh, and for the PowerUp Magazine for giving COMSOL the opportunity to basically present its simulation capabilities, right? When it comes to reducing the testing and validation cycles in the electric vehicle industry, because we see that we need to deliver the products faster to the market, right? So in that sense, adopting advanced simulation techniques makes sense, right? So yeah, so I'll just start off by sharing my screen. Okay, when it comes to simulations in the automotive industry, so we have the conventional simulations, right? So which is the conventional drivetrain that we have, which is the internal combustion based, right? So we have the internal combustion engine, then we have the gearboxes, then transfer cases, differentials. So we have the conventional drivetrain simulations. And so today, so we need to move on to the modern electric vehicle drivetrains, right? So that would involve batteries involving different chemistries, and then the gearboxes, then the different power electronics devices, right, such as the three-phase inverters, and then finally to the most complex part of the drivetrain, which are the different kinds of motors, right? So be it the induction motors or the conventional PMSM motors, right? So to do the simulations in throughout the range of the drivetrain, so COMSOL multiphysics is very beneficial. So here on the screen, you can basically see the different kinds of simulations that you can do when it comes to the electric vehicles, right? So on the top, top left, you can see the large eddy simulations. So these are the CFD simulations that are performed on the automotive, basically the exterior. So then we have the conventional, the exhaust case manifold CFD analysis here. So moving on to the more modern simulation, so we have the battery pack simulations, right? So in COMSOL, you can do electrochemical simulations ranging from to the very basic electrode level simulations until the battery pack level simulations, right? So we'll look into the more case studies as well as we go on. So then we have the fuel cell simulations as well, right? So these are more advanced electrochemical fuel cells. And this basically you can couple with the other physics, right? So you can do advanced fluid structure interaction studies, thermal structure interaction studies, so electrochemical thermal studies. So the main USP of COMSOL is its multiphysics capabilities, right? And all of it you do in one single graphical user interface. So we'll start off with the batteries and fuel cells, right? So ranging from the thermal management. So here you can see the jelly roll analysis, right, of a simple cylindrical battery cell, right? And that you can extend from an electrode level analysis to a detailed battery pack level analysis as well, right? So with hundreds of cells. So here you can basically couple different kinds of analysis such as lumped model or 1D analysis with the more complex high fidelity 3D analysis as well, right? So you can do different kinds of battery pack level analysis such as the thermal runaway analysis or the nail penetration analysis, right? So this is relevant to the batteries. So moving to the fuel cell electric vehicles, so we can do the fuel cell unit cell modeling as well, right? And ranging from that to the advanced fuel cell stack level analysis as well. All right, yeah. So modeling of batteries and fuel cells. So if you look at the animation here, you can basically see the thermal runaway propagation analysis that has been done at a scale, at a pack level scale, right? And so we have different validation models as well in the application library. This you can basically go to the COMSOL's website and gain access to these models as well. Yeah, you can model different kinds of battery degradation mechanisms as well, right? Such as the solid electrolyte interface formation, due to which there is pack performance degradation. So then there is mechanical degradation, or the intercalation strains that form due to the as a result of mechanical degradation. Then the lithium plating, gas evolution, corrosion at the basically at the electrodes. So all of these degradation effects can be captured in your model. So let us now look at one such case study. So this case study is from Murata, right? So they're based out of Japan, and they basically they try to analyze how they can reduce the dendrite formation. Right? So these dendrites are they are like needle-like structures that are basically formed at the lithium electrodes, right? And so to reduce this, you can take a couple of approaches, right? So one is purely chemical or electrochemical approach, and see how changing the different kinds of chemistries can reduce the dendrite formation. And another novel approach that the engineers at Murata took is basically to see how basically supplying the electricity to the electrodes can reduce the dendrite formation, right? And basically by changing the pattern of electrical supply to the batteries, they were able to basically increase the life of the battery by up to 4 times, right? So this was one such novel case study. And this is another case study. So this is from Toyota. So they have been a long-time user of COMSOL multiphysics, and so this application is basically in the fuel cell area, right? So here they basically try to the model the reactant channels. So we have the oxygen and hydrogen that combine on the reactor surface. So basically they did a topology optimization of this reactor bed. So they were able to obtain very intricate topology optimized geometry. Right? And this is what we call as the generative design. Right? So this is basically inspired by the natural structures such as blood vessels in the humans, or even the veins in the leaves, right? So these are what we term it as generative designs, and they were able to obtain such designs by performing topology optimization in COMSOL, right, for the reactor bed. Yeah, so COMSOL offers many advanced algorithms when it comes to different kinds of optimization, such as basically parameter, shape, or even the topology optimization techniques. Right? Yeah, so you can also extend your study with modeling the corrosion. Right? Here you can see an example of an electrocoating process for corrosion protection of a car door. Right? So you can do a very fundamental electrochemical analysis as well in COMSOL. So based on the corrosion features, so here is another case study. So this is from HZG and the Daimler Corporation that is based out of Germany. Right? So in automobiles, so these are these, especially the outer components, they have different layers of metals, right? The outer shell. So because of different layers of metals and the way they are held together, basically by the rivets, right? So this basically leads to the galvanic corrosion of the metallic components, right? And they modeled the galvanic corrosion phenomena in their door components, and they were able to basically get the current density in the electrolytes, right? So they were able to identify the hotspots where that could lead to the highest rate of corrosion, and they were able to take certain preventive steps to prevent the formation of corrosion at these regions. Yeah, so now that we saw the different chemical and electrochemical phenomena that can be modeled for automotive applications, now let us go to the more conventional side, right? But these kinds of analysis can be applied to the modern EVs as well, right? Such as using the rotor dynamics capabilities in COMSOL. So you can model different kinds of bearings. Right? So for example, there are many high-tech bearings that are present in the electric motor. Right, you can basically investigate different standards and different loading standards that needs to be applied when it comes to different power levels, different kinds of electromagnetic loading, right, that are there on the motor bearings. Yeah, you can also do different kinds of critical speed analysis, right? So such as the shaft whirling analysis. You can basically do different kinds of stress limits that needs to be obtained for that particular configuration of motor, right? And here is one such example. So this is for a conventional crankshaft of an IC engine, right? So when I say multiphysics, here you can see one such example, right? So here the multiphysics is in the sense you can actually model the exact hydrodynamic bearings, right, at these locations, and you can see the film thickness, the thin film pressures, and also finally the critical whirling speed as well, right? So that is truly a multiphysics approach. And console is what you call as a white box, right? So all of the underlying governing equations are clearly visible in the GUI itself, right? And since this is a general purpose software, you can also modify the underlying equations as well. So for example, if you want to add a certain kind of source term to any of your equations, you can do that very freely, right, by enabling the equations feature in console. So it is very flexible in that sense, right? So you can extend your electromagnetic analysis, right, by doing an acoustic analysis as well, right? So, or what we call it as noise, vibration, and harshness analysis, right? And so here you can see one such example here for an electric motor, and you can see the different acoustic pressures so around the housing as well, right? And you can see the resulting stress distribution as well because of the electromagnetic forces and the resulting vibrational forces as well, right? And you can also see the rotor orbits for the bearings here as well, right? Yeah. So here is another example of gearbox vibration noise analysis, right? So this is once again an example of noise, vibration, and harshness analysis of the gearbox, right? So this is once again a multiphysics example that couples the multi-body analysis, structural analysis, and acoustics analysis. Right. So once again, you can do automotive acoustics for the entire car cabin as well. So we have wide-ranging functionalities when it comes to that. And so relating to that, so we have a case study. So this is from Harman International, right? So they basically use the acoustics feature that is present in console to study, the different placement locations of their speakers, right? So where they can obtain the optimum sound output. So this is one such user story. So this is from Harman International. Yeah, so you can also model applications such as the ultrasonic car parking sensor. So here you are basically combining different forms of numerical methods as well, such as the finite element method, finite element model that can be used to set up your the ultrasonic parking sensor, right? And that you can couple with the ray tracing feature that is there to basically investigate how that particular ultrasonic waves is propagating and reflecting back to the receiver. Yeah, so this is once again a multiphysics phenomena, right? So this combines the solid mechanics, electrostatics in the parking sensor itself, and then the pressure acoustics. Right. So now we saw different features, capabilities when it comes to the chemical, electrochemical, then the structural and acoustics part. So now let us see how a console can be helpful in modeling or optimizing your electric motors as well. Right. So for that, we have the AC/DC module. And so using this module, you can model very basic electrical components such as the resistors, capacitors, capacitive devices such as touch screens, different kinds of position sensors, different kinds of MEMS-based sensors, motion sensors, right? And also very complicated devices such as different kinds of motors as well, right? Such as the induction motors, PMSM motors, or even the linear motors. You can do analysis at electronic scales as well. Right, so electronic semiconductor level analysis, PCBs, cables. You can do shock testing, various kinds of battery pack drop testing analysis, right? And when it comes to the optoelectronics, you can model different kinds of LEDs, right? And you can do various kinds of optical analysis as well. Right? Console also offers, a very wide feature set, be it the material models, different kinds of geometries, right? Ready-made geometries, and also has the, what you call as the proof of concept models, right? So these are validated models, so that are readily available in the application library. Right? Yeah, so like I was mentioning, so COMSOL offers very dedicated features when it comes to modeling electric motors of different configurations as well, not just the radial motors, right? Also the linear motors that sees a lot of application when it comes to the magnetic levitation applications for the locomotives, for example. Yeah, you can, of course, do very basic, efficiency map calculations as well. So this considers the effect of temperature rise as well. Right? So we need to consider the effect of temperature rise because the efficiency, is very much dependent on the losses, electromagnetic losses, right? And this leads to temperature rises. So you can also obtain temperature maps as well. So yeah, you can also integrate different kinds of cooling methods as well, such as the regular natural convection. So for motors which has the conventional fins, right? Or you can also explicitly model very advanced liquid cooling functionalities as well, right? Using the CFD capabilities that are available in COMSOL. Right. So combining these features and functionalities. So let us now look at a case study. So this is from FZB technology. So this is based out of US. Right? So they basically used COMSOL for designing an electro-hydraulic hybrid kind of a steering mechanism for an automotive customer of theirs. So they basically, modeled the electromagnetics, structural mechanics, fluid dynamics, acoustics, and also the CFD and heat transfer as well. Right. So this was a truly a multiphysics kind of an analysis that they did to basically increase the efficiency of their the entire system. Yeah, so this is another case study from Bosch. So they have been one of our long-term users as well. So basically they have done a thermal management, right? So this is once again a multiphysics of electromagnetics and CFD and heat transfer, right? Of a DC link capacitor. So DC link capacitors are very crucial components that are in the three-phase inverters, right? And these three-phase inverters sit between the motor and batteries in an electric vehicle. And DC link capacitors are prone to high thermal fluctuations, and they're also prone to very constrained size as well. Basically considering these two factors, the researchers were able to do truly coupled multiphysics analysis, and they were able to optimize the entire component inside the three-phase inverter. Right? Yeah, so you can extend your basic electromagnetic, structural, and acoustics analysis that you have done on your electric motor and optimize for different features as well, for different objective functions, right? So for that purpose, so COMSOL has different methodologies when it comes to optimization. So COMSOL offers a parameter, shape, and topology optimization, right? And so one major benefit of doing optimization study in COMSOL is that you can couple all the relevant physics inside your model, right? So be it the electromagnetics, heat transfer, structural mechanics, or even the acoustics, right? So your objective function can be any of from any of this physics, right? And here on the top, you can see basically see the topology optimization study that has been performed on an axial flux motor, right? So you might have basically read that one of the OEMs based out of Bangalore. So they basically designed an axial flux motor for an electric truck right application. So yeah, that is one such application. And so Volkswagen. So this is a case study from them. So their research center that is based out of Kassel in Germany. So they used COMSOL to essentially do topology optimization of the various magnet domains inside the electric motor. Right? And basically by doing this topology optimization, they were able to increase the torque output by up to 30% while reducing the magnet material by 10%. Right? So that leads to major cost savings because magnets are one of the the highest costing component inside the motor. Right? All right. So we basically covered like most of the aspects of modeling in the electric vehicle industry, right? Starting from the pack level, battery pack or the fuel cell analysis, to the structural noise vibration harshness analysis, and finally to the electromagnetic analysis as well. Right? So this covers almost the entire gamut of designing an electric vehicle system. Right? So yeah, so to aid that, so COMSOL offers different kinds of modules, right? So be it the electromagnetics, fluid and heat transfer, structural and acoustics, or even the chemical part, right? And so there are different modules, and if you are trying to solve any complex problem, right, and so we request you to get in touch with COMSOL so that we can assist you, basically solving that problem. All right, so we can log into comsol.com, and there you can see different kinds of blog posts from many of our customers, user stories, videos, and you can also download COMSOL models as well if you want to, basically. Yeah, so if you have any particular requirement, you can download that particular model as well in the models and application gallery of comsol.com. Yeah, so with this, I've come to the end of the presentation. So if there are any questions, so feel free to ask them.
So thank you, Mr. Sharad, for this wonderful presentation. If there are any questions, then participants can raise their hand and ask actually.
Sorry, I didn't understand.
So, Sharad, thanks a lot for this wonderful presentation, making complex problems simple with the help of the software that you have. So, if there are any queries, they can still participant can ask in the chat box also, so that we can he can answer it later also during the session.
Yeah, thank you, Santosh, for the opportunity.
Yeah, thanks a lot for this excellent and insightful session. So we have our next speaker. Yeah, he is Mr. Pallav Chaudhary. He is the director of Hyperion Chargers Private Limited. Before I hand over to him, a brief introduction to him. Pallav Chaudhary is the director of Hyperion Chargers Private Limited. He's a visionary entrepreneur leading groundbreaking initiatives in electric vehicle charging infrastructure. He holds a bachelor's degree in mechanical engineering from Vellore Institute of Technology and a Master of Science in Industrial Engineering from Northeastern University, Boston. Pallav's entrepreneurial journey began in 2020 with the founding of Hyperion Chargers, driven by a mission to enhance India's self-sustainability in EV infrastructure. His philosophy emphasizes proactivity and quality, reflected in Hyperion Charger's commitment to innovation and excellence. Under his leadership, Hyperion Charger aims for significant growth and impact in the EV charging sector, contributing to a cleaner, greener future. Pallav's story embodies a blend of academic excellence, industry experience, and a passion for driving positive change in sustainable mobility. Today, he is going to speak on from Make in India to Charge in India, building a sustainable supply chain. So, Pallav, welcome to this virtual business meet, and I would request you to take it forward from here.
Thank you so much, Santosh, for this opportunity, and thank you, Smart Energy Magazine, for giving me this opportunity to say my piece here. I'll just start on by sharing my screen. Good afternoon, ladies and gentlemen, distinguished guests, and fellow advocates of electric mobility. I am very happy and honored to be here to be a part of the PowerUp EV business meet. I'm sure it's an electrifying gathering of minds dedicated to shaping the future of transportation. As a proud sponsor of this event, I am deeply honored to address you today on a topic which is of a paramount importance, in my opinion, and it is something which is close to my heart as well as our company's motto. It is from Make in India to Charge in India. on how to build a sustainable supply chain for success in the EV sector for India. So the things I'm going to cover, I'm just going to give you a brief on it. I am just going to cover of how the Indian landscape of the EV industry looks like. Why should we do Make in India to charge in India? And how is Hyperion Chargers helping in that progress? So the first thing, as you all know, let's delve deeper into the dynamics of India's electric vehicle landscape. You now know that the Indian EV market is not at all now a nascent EV stage. It's been growing since the past 6 to 7 years. And as the data I have gotten from the SMEV online database, the annual average growth rate has been roughly about 339.57% for electric two-wheelers, 49% for electric three-wheelers, and 117% for electric four-wheelers, which is a huge amount when you see, because no one expected our EV industry to grow at such a big pace. And it's been growing at a tremendous pace for us. And, the winds of change are blowing in the favor of electrification is all I can say. And by 2030, as we all know, India's aim is to electrify 30% of its automotive fleet, signaling a monumental shift towards sustainability and innovation. And we all know the major players who are helping us doing this is Tata Motors, Ola Electric, MG, Ather, Hyundai, Mahindra, to name a few. And this landscape change is even more, helping India with growing in this industry, because we can see the acceptance, we can see people wanting to shift towards, electric mobility, which wasn't expected to be so fast, but it's a very positive reinforcement. And all we can say is, I think we as an EV industry have to be prepared for a much better growth rate and a much better response from the customer base. Moving forward, the growing in EV industry, of course, it's the market size, as we all know, is a huge market size. And as per the Grandview research, which I had gone through, the electric vehicle market is growing in India by a CAGR of roughly 94.4%, which is a huge amount. And the estimated value of this industry is to be $152.1 billion by 2030. And considering that, it's not a small amount. And I think a lot of startups are coming up, growing into, and it's not only the dependency on other companies, other countries. I think Indian EV sector, Indian EV market is being supported by a lot of Indian EV startups. You have big startups like Blue Smart Mobility, Charge Zone, you have Pure Electric Vehicles, you have Cell Propulsion, Loham, etc. And that change, in my opinion, is seen in this industry, which is very, it's very satisfying to see that, the Indian startup industry is stepping up to the demand of the EV market here in India. Moving on, I think me coming from the charging infrastructure segment, I would like to put a little bit of a focus on, how the charging infrastructure is playing out in the Indian landscape. A lot of countries who have been successful in adopting the EV mobility, countries like China, US, Norway, Japan, all of these countries have one thing in common, that they have maintained they've maintained a lower than world average of EVs per charging point. Now, EVs per charging point becomes very important in electric mobility, especially in my opinion, as instead of being working in an ICE car, using an ICE car, it takes roughly less than 5 to 10 minutes for you to fuel your car and set for 7 to 10 days. As opposed to that, if you go to a public charging station, you need at least 30 to 45 minutes to charge your electric vehicle. And that's where, availability of these charging points, the number of electric charging points per EV becomes a very big factor. Because if there are not enough points again, the charging infrastructure system goes down the drain. So in our opinion, if India also needs to be ready and prepared for this electric mobility sector, we also at least, if not lower, but we at least need to maintain the world average of EVs per charging point. And if we consider that by 2030, if 9.6 EVs per charging point, which is the world average, we would require roughly about 15 lakh charging points across the country. That is 15 lakh working, deployable charging points across the country, which is a huge number. It is not an easy task to have those many charging points deployed in a country within a small time frame. And that's where my point comes up of, you know, the need for localization. Why is localization of the supply chain, especially in the charging infrastructure industry, required? In my opinion, the two major points that are required. As I said, we need to have 15 lakh charging points across the country in working and charging condition. So those are the two major points where we feel that the Indian supply chain and the localization of the supply chain in the charging infrastructure can play a very huge role. 15 lakh charging systems would require a huge amounts of components, especially like if I come from a connector industry, every charging point would have roughly about 2 connectors per system. That is roughly about 30 to 35 lakh charging connectors. So having so much requirement in a country requires a robust localized supply chain. And also, as I said, it has to be in a working condition. Now, when I was traveling from Mumbai to Pune in the past year, I stopped at the expressway rest stop where there were 3 to 4 DC chargers deployed. But unfortunately, none of them were in a very good usable condition. 2 of them were completely out of service. One of them was in a condition that you'd probably not use your new EV to charge. You'd not use that charging point to charge your new electric vehicle. And the one you might use it. You see, like out of 4, there's only one charging point that you might use to charge your new electric vehicle. That's a very sad situation when you see all of these chargers were deployed 3 to 4 years back, and they were majorly deployed by foreign vendors. Now, I think designing and manufacturing products, especially in a country like India, where the customer viewpoint, the customer usage, the use cases are completely different. Indian vendors are more capable of designing and manufacturing products that would suit the Indian environment, in my opinion. And also, if there's a company based out in Bombay who has deployed these chargers rather than a company based out in China, I think those charging points would have been up and running, because after sales service and faster maintenance is possible for these chargers or charging systems and their components if Indian vendors are involved rather than foreign vendors. Now, coming up to why make in India to charge in India, I think there are 4 major key benefits of localization in our opinion. One, we all talk about how we are building a sustainable mobility phase. We are building something which will help the environment, reduce our carbon footprint, and help meet the help meet the carbon emission milestone that we have set by all the countries. But importing parts, importing components, importing chargers, or importing anything in the EV industry has an increased carbon footprint than you would have it if you localize the same thing, which I'll discuss more in detail by a small case study that I've taken. As I said, of course, the response times for maintenance, for services, for after sales replacements is always going to be faster in India. and it's always going to be much faster. Of course, a company who has to do service on the Mumbai-Pune Expressway and the company is located in Mumbai can do it in the same day, as opposed to a company who set it up from China will take at least 3 to 4 days, 5 days, 6 days to come and do the service. So I think faster response times, more uptime for the chargers or for any other components, less downtime. That is a very big benefit of localization in our opinion. Of course, support for local economies. You always, if you localize your supply chain from the country, it will always help the smaller companies, the startups from your country to grow into larger giants and become big corporates to, battle it out on the world level playing field. But if you're only going to, move these components, import them from other already giant companies from around the world, then it doesn't help the Indian growing economy. If we are to become from a developing country to a developed country, I think supporting the local economies and increasing localization in a sector which is fairly new and is much more easier to for localization to be done in this industry rather than any other industry. And as I spoke, the fourth and the major is the enhanced quality control. Indian vendors know the basic use cases, how the customers will utilize their products, how the maintenance of these products will be done, and they know the environmental conditions of this country. So better products can be designed in a way which can, satisfy the use cases of this country. Now, let me shed some light on two of the major points that I spoke about. First of them is the economies of localization. As I mentioned in one of the previous slide, the EV industry is set to grow at a CAGR of 94.4%, which is valued at $2.1 billion. And as per the Economic Survey of India, it is predicted to generate over 5 crore jobs in India alone by the end of the year 2030. But right now, India is dependent on other countries for over 70 to 75% of their components and products in the EV charging industry alone. And they're only locally sourced, the share of locally sourced products is only 10 to 15, majorly 20% as of 2023. And I think the other components such as batteries, traction motors, and controllers follow the similar trend. It means foregoing almost roughly about $106 billion in revenue to foreign countries, and at least 50 to 60%. I agree, the entire 70 to 75% of the products cannot be localized, but at least the locally sourced share can be increased to 50 to 60% in these industries. And there are a lot of Indian startups, there are a lot of component manufacturers that are growing in the country, which need the support from the larger giants in the country who are working in the EV industry, in the EV charging industry, to locally source these components rather than getting it imported from other countries like China, South Korea, Japan, or Europe for that matter. The next point was, as I said, the carbon footprint difference. When we import these products, we never think about, what the difference in our carbon footprint would be if we are, importing it or we are locally sourcing it. So I just took a small, test example. I just took a small shipment of 100 Type 2 connectors, which weighs roughly about 230 kgs. When it's shipped by air from Shanghai to Mumbai, it roughly, causes 751.73 kgs of CO2 emission. And yes, there are other ways to get it, not by air, by ship. But again, the wait time, the MOQs are so high that most of the companies who are buying in smaller quantities would always prefer to get it by air. And at the same shipment, if I send it where we're based out of Baroda, if the same shipment I send from Vadodara to Mumbai by air shipment, it only costs, it only emits roughly about 115.87 kgs. There's roughly 7 times more CO2 emitted when you are, importing importing your parts. And if the same shipment I send from through trucks or by road transport from Vadodara to Mumbai, the emission is only 10.5 to 58 kgs. That's roughly 70 times saving of CO2 emissions. And I think that's a very big point where we claim ourselves, our industry, to be a sustainable industry. But I think if we are negating this carbon footprint difference from locally sourcing these components to importing it from countries, I get the point where there are certain products, certain components, and certain parts that can only be imported and are not available. The technology is not available in India. That is a different story. But there are at least 50 to 60% of these components that the technology is available in India, and I'm sure they are, if not better, at least at par with the Chinese or the European counterparts. So, how is Hyperion? How are we, playing a part in this localization of supply chain? Just starting giving you a brief about what the company is, how we came up. So Hyperion Chargers was launched by me during the lockdown period that we had in India during the COVID lockdown. And as soon as we opened, we incepted Hyperion Chargers. 2 years it took us to go through our R&D phase where we developed our connectors to meet the standard requirements of the international market, as well as the customer use cases and the customer demands in India. And we officially launched our Type 2 connector, which is called the Skyros EVG, which is our flagship product. We actually started as a charger manufacturer when we incepted the company, but we saw, as I said, the localization was a big issue where a lot of charger manufacturers had to depend on external companies, foreign companies to import these components. That's why we shifted from being a charger manufacturer to a component manufacturer. And in November of 2023, we received the highest certification possible for our product, which is the IC certification for our product. So we have two major offerings as of now. We have the Skyros Type 2 AC charging guns, which we developed from 3.3 kilowatt up till 22 kilowatt. And we have the parking sockets to hold these charger guns in place for all the charger manufacturers. So our unique selling proposition has always been make in India. It's not like I'm asking everyone to go local, but we walk the walk and we talk the talk. We also make sure that all of our products are locally sourced. 100% of our products, not even a single screw or a single resistor, comes out of the country. They're all locally sourced, and all of our major vendors are from Gujarat and Maharashtra, reducing our carbon footprint difference as well. And we want to make sure that localization and make in India is always at the core of Hyperion Chargers Private Limited. So these are some key clients that we work with. In the past 2 years, we've been working with some of the key clients being Bolt Earth, Tyrex Chargers, Bright Blue Mobility, iElectric, and Kazam. So we've been the trusted connector partners for all of these companies, and we've been supplying to them since the past 2 years. I think that's there. I think ending on a note, I would say that, as we chart a course from Make in India to Charge in India, let us not lose sight of the electrifying potential that lies within our grasp. Together, let us harness the power of innovation, sustainability, and collaboration to drive India's electric revolution forward and pave the way for a brighter, cleaner, and more electrifying future. Thank you for joining me on this electrifying journey. And remember, the road ahead may be winding, but with the right charge, we can power through any obstacle that comes our way. Thank you.
Thank you, Pallav, for this wonderful presentation with your focus on Make in India. It is definitely a nice initiative. If there are any questions from the participants, they can ask him actually. You can raise your hand and then ask the question. So thanks Pallav for this for delivering this engaging and knowledgeable session. And if there are any questions, we will take it later on in the series. I would request the participants, if they have any questions specifically to Pallav, they can uh, put it in the chat box that is there. So moving on, our next speaker is Mr. Nitin Sabharwal. He is the founder and CEO of EV FinServe. Before I hand over to him, I would briefly introduce him to all. Nitin Sabharwal is the founder and CEO of EV FinServe, a Noida-based VC platform established a year ago, specializing in financing electric vehicles in rural areas of Uttar Pradesh, Bihar, and Madhya Pradesh. EV FinServe collaborates with over 70 original equipment manufacturers and 400 dealers, offering products such as L3 e-rickshaw and batteries, with plans to soon finance two-wheelers as well. Nitin boasts over 27 years of experience as a career banker with leading banks and non-banking financial companies. His prior role as the CEO of an NBFC focusing on MSME and commercial vehicle loans highlights his profound understanding of the financial sector and his adeptness in navigating its complexity. His leadership at EV FinServe exemplifies his commitment to driving financial inclusion in the EV sector and beyond. Today, he is going to speak on driving change, financing solution for India's EV revolution. I would request Nitin Sabharwal to take it forward from here.
Thanks, Santosh. Thanks a lot. And so this is going to be slightly different from what we've heard so far. So this is how the actual customer gets to own the asset. So what we do is at EV. So we started about a year back, and we're a bunch of ex-bankers. So we finance e-rickshaws in UP, Bihar, and parts of MP. Very recently, say about 3 months back, we have also forayed into battery financing and battery leasing. And as you mentioned, we're also, shortly getting into EV two-wheeler financing as well. So there are, clients are, it's a good time to be an EV client. There are multiple products available for a client. There is regular loan financing. We also do some operating leases as well, where the margin money is much lower, and the monthly lease rental is also lower. So it makes sense for a client to just rent it out instead of purchasing the entire vehicle upfront. We're also working on a subscription model, wherein what we do is we refurbish used e-rickshaws, and we do a subscription for a year and a half, and this is one of the major pain points for all the finances currently. There is no secondary market available, so we're trying to make it slightly more organized. It helps the client, helps the finances as well. Very recently, we started lead acid battery financing. We started lithium ion leasing as well, and batteries is one of our main focus areas for this year. We feel that the battery market is eventually going to be much larger than any of our products what we're currently doing. So this year's focus is going to be on batteries. We did close to 25 crores of AUM last year, and so just to put things in perspective, last April 23, when we started, we did about 17. We disbursed about 17 vehicles in April 23. We did close to 450 plus last month. So our plan for this year is to manage an AUM of over 200 CR, and which is primarily going to be driven by e-rickshaws, but batteries are going to play a major part there. What we offer so we have multiple lending partners. So what we offer is a built up infra which is already in place. We are currently present in about 115, 120 locations with our own manpower in place. So for a lending partner to come in, instead of building up his own infra, it makes sense for him to be a part of our infrastructure, choose what geographies, what products he wants to do, and we can manage it for him. So it makes sense for all. We currently operate at a 0 NPA level, and our current run rate is about 5 CR a month. So and you know we bring a small part, and we really hope that what we've seen is that this product has the potential of making a large difference in the client's life. When he buys a e-rickshaw, the moment he drives out of the dealership, he starts earning actually. So so we're playing a small part in financial inclusion as well, and hope to continue doing so. So any questions from any of the participants? I'll be happy to take it up.
Can we get the help from the government for the set up the charging station, like any startup and any funding from the government for the any subsidized loan?
See, there are a lot of organizations today, a lot of NBFCs today, a lot of lending companies today, which do provide financial assistance for setting up a charging infra. So one does not need to actually look at the government for help anymore. There are facilities available, and all you got to do is just probably search online, and you'll find multiple opportunities available. So there is funding. So for example, we fund the retail client. At the same time, we have plans to fund the dealer network as well for dealer funding, because our core business revolves around that. However, there are companies which focus on the entire green infra as well, which where what you're asking for is a major portion of what they will be planning to do actually. So if somebody is an entrepreneur, wants to set up charging stations, there is financing available for that. I hope
Thanks.
that.
Yeah, thank you.
All right.
Okay, so let's move on actually. We have our next speaker, Shipra Sinha. She is the Director Marketing and Communication at Light Mechanics. Before I hand over to her, I would like to give a brief introduction. Shipra Sinha is the Director Marketing and Communications at Light Mechanics Private Limited. She is a pioneer leader in the e-mobility sector, currently serving as the Director of Marketing and Communication at Light Mechanics Private Limited. With a background in banking, Shipra made a bold transition to the laser industry, where she immersed herself in mastering the technicalities of welding. Her passion for innovation and learning led her to become a renowned expert in lasers, particularly in the context of electric vehicles. In her current role, Shipra leads the e-mobility laser solutions business at Light Mechanics, where she has been instrumental in revolutionizing the industry. She anticipated the growth in the EV sector and focused on manufacturing laser welding systems in India, bridging a crucial market gap. Shipra's exceptional leadership is evident in her customer-centric approach, technical expertise, and dedication to supporting the EV industry's growth locally and internationally. Shipra's journey exemplifies the power of passion, perseverance, and dedication in driving positive change in the e-mobility sector. Today, she is going to speak on revolutionizing EV manufacturing, trends in welding, joining, and the role of laser technology in scalable production. I would request Shipra to take it over from here.
Thank you, Santosh ji, and thanks for having me here, and thanks for your question. So we all have EVs on our mind today, right? And that's very good to know. Now, coming to the topic, I would like to start with a very significant trend that I see is that as we are transitioning from IC engines to batteries and powertrains, we are actually racing against time. It took the combustion engine around 50 years to reach to a level of maturity, and the EV industry is pushing to achieve the same goal in the next coming 10 years. Considering the huge concerns we all have over global warming. So let me quote you some facts here on the current scenario that is prevalent worldwide. is that around 28% of the global carbon emissions and 61% of global oil demand is coming just from the transport sector. And these emissions are going to double by the year 2050. So the pressure is definitely huge on all of us. And here is where e-mobility comes to play a huge role in decarbonizing and reducing the pollution levels. So basically, e-mobility is not just a trend. It has become a necessity for all of us as of now. In the current scenario, we see that the whole R&D towards EVs are directed mostly towards making vehicles as lightweight as possible to increase mileage and performances, and towards making safe and reliable battery packs and powertrains. Now, this energy transition is significantly increasing the demand to weld or join conductive, dissimilar, and lightweight materials in EV manufacturing. Now, talking about batteries, we see that the cell chemistries are not stable and not mature yet as of now. The OEMs are still figuring out the kinds of cells they would like to use, or the kind of metal bus bars they want to use, the kind of thicknesses that they want to use. The cell technologies are changing day by day, and the EV industry is evaluating various types of metals like copper, aluminum, nickel, stainless steel, different kinds of alloys, and even clad materials with different thicknesses. So it has become the need of the hour to choose a joining technology which can, process all these design changes and all these material changes with much ease. Now, how do we define the basic criteria for welding and manufacturing? Answer of the question is very simple. The basic criteria for effective welding is more or less common for almost all EV applications, which includes having reduced heat affected zones, or having high quality and strong welds with lowest contact resistances, or minimizing the spatters, because spatters actually means material removal from the weld joints. So any OEM or any person who welds will try to eliminate spatters from the weld joints. Ability to weld similar and dissimilar metal with ease. And another criteria is the ability to have heat, to weld heat sensitive thin strips without burning them out. And of course, the OEMs are also planning to scale up the production volumes with high precision and high process speeds, which typically would range anywhere from 200 to 500 millimeters per second. And all these requirements have presented critical joining challenges in the past. And what I feel is that the one joining technology which works well for almost all EV applications is laser. In fact, just like the EVs, the laser technology is also continuing to grow and get more and more sophisticated. And due to this, we see that the use of traditional and conventional methods of welding like resistance, ultrasonic welding, TIG and MIG welding are taking a backseat, paving way for the use of high-end lasers for faster, finer, and high quality welds with the ability to, also monitor weld depths in line. And yes, we have sophisticated lasers which can weld dissimilar metals as well. So basically, we used to have a notion in the industry that lasers are unable to process welding of dissimilar metals together, which is now a thing of the past. So we have high-end lasers today, which has the ability to weld the most complicated and the most trickiest kind of weld applications very successfully. So next, I would like to explain how lasers can be used to refine and scale up EV manufacturing in India. So basically, implementing new technologies is always a risk for almost all industries, not only EV, but almost all industries. And as we all know that the EV industry is growing very, very fast. So the time to market is of special importance here. Basically, what's good for small volume productions may be a drawback when one plans to increase the volumes or are eyeing to target huge production volumes. So keeping this in mind, there has been a lot of discussions in the industry regarding adopting lasers for EV welding processes. The initial investment of lasers might be a little high, but you have to understand that the return on investment is much faster in high volume production lines. So the high procurement expenses basically is offset by excellent weld quality and high processing speeds. So when I talk about speeds, what kind of speeds I am talking about? Laser welding machines can be 5 times faster than TIG welding, 5 to 10 times actually faster than TIG welding, 3 to 5 times faster than MIG welding, and 4 to 5 times faster than resistance welding. So it provides the lasers also are known to provide the most consistent, strong and reliable welds with lowest contact resistances, which is I think is very important in the EV industry, not only in batteries but also in the powertrains domain, that the contact resistance should be as minimal as possible. The second advantage that laser would give is that it minimizes thermal heat damage to heat sensitive materials. It has very low heat affected zone, and the heat generated by laser is not very local. It is very local. It's not global. So it's the heat dissipation to the cells or the heat dissipation to other components is very low. The quality of the welds produced by laser is also very fine and strong, and this reduces any kind of post-processing applications like buffing, grinding, polishing. These all post-processes are basically eliminated when one plans for laser as a solution for welding. And it also helps in saving a lot of time, cost, and effort undergoing such kind of post-processing. Lasers can also be integrated with inline weld monitoring systems, which can check weld depth penetration inline. So any weld defect can easily be traced and rectified. This monitoring helps achieve 100% quality control, which totally eliminates the need of any kinds of destructive testing, which in turn will also help in reducing scraps and increase the overall throughput. Laser also requires very less space and are basically maintenance-free machines and can be run 24/7 to help increase the production volumes. So basically the downtime of the laser is very low. Plus the most complicated kind of weldings like the welding of copper hairpins in the powertrains domain, the welding of clutches, gears, along with high-speed welding of the body in whites by providing 4 times higher strength as compared to resistance welding. So laser plays a very big role also in the welding of dissimilar reflective metals as well. The problems of welding, which are very generic in nature, like porosity problems, the problems of humping, lack of fusion, weak weld joints, cracks in the welds. All these can be easily managed by selecting the right kind of laser and the right kind of optics for your application. And of course, not to forget the right selection of welding parameters. So in a way, we can conclude that lasers are very well positioned in the EV market as of now to assist across the entire EV value chain of manufacturing. today the scenario in India is such that we are no longer dependent on China or other European countries to import high-end laser systems. We have the technology readily available in India. We have local integrators who have the expertise in manufacturing high-end laser welding systems integrated with vision cameras or high-speed gantries, inline well monitoring systems. So all these solutions are easily available in India today with local service and support. So I strongly believe that if the Indian EV supply chain is able to collaborate efficiently, together we will be able to transform India from becoming a consumer economy to become a producer economy. So that would be all from my side. Thank you very much. Let me know if you have any questions.
Yeah, thanks a lot, Shipra. And actually, you have mentioned it very clearly that uh, to make India from a consumer country to a producer country. So I guess more or less the aim is the same, and that's what our Prime Minister is also pushing for. So I guess there is one question in the chat box. If you can answer that, it would be great actually.
Okay.
Yeah,
I'm not
I
able
would
to
read
see
it.
the chat box. Can you read?
No,
Yeah,
I would.
just
Yeah,
one second.
is Mr. Vishal Walke. He wants to know: is there any process or tool to identify whether the welding is hampering the cell or not? I would repeat: is there any process or tool to identify whether the welding is hampering the cell or not?
Yes. So basically, it's the idea here is, whenever people come to us for welding of their batteries and welding of their cells, we always suggest customers to have the thicknesses of bus bars lesser than the terminal thickness. So just to ensure that, the heat affected zones, or there is the heating is very minimized, or, the penetration is very controlled. If you talk about something wherein you can integrate into your laser welding system, as I was also explaining, that we have something called inline weld monitoring systems, which can be integrated with the laser welding systems itself, which will be able to check the penetration for each and every weld that you do. So it is like a 100% quality check for you for your components. Talking about like how so you can actually set thresholds there. So suppose if you don't want the penetration to be more than 5 mm, you can put a minimum threshold of 5 mm. So if the penetration exceeds because of some reason, or if the tolerances are not met within the threshold set by you, then the inline weld monitoring system will show an error that this problem has happened and you need to rectify this issue. So you can actually trace this actually. Hope my answer is clear.
Yeah. Any more questions to Shipra? Okay, fine. So I guess we can move on, and let's see if there are any questions that come up later, then we can take it. So this was Shipra Sinha. Uh, and thank you for delivering an informative and insightful session. So moving on, we have our next speaker, and she is Kasturi Gomatham. She is Global Head of EV Partnership and Battery Swapping at Shell. Before I hand over to her, I would like to give a brief introduction. Kasturi is a seasoned mobility professional renowned for her impactful contribution to the decarbonization of transportation, beginning her journey as a chemical engineer at Daimler in Germany. She focused on reducing emissions from trucks, laying the groundwork for a distinguished career in mobility. She later transitioned to management consultancy at PwC, advising automotive OEMs in new markets before optimizing logistics for e-commerce at Flipkart. As an early member of Ola Electric, Kasturi played a pivotal role in advancing electric two-wheelers in India. Her tenure at Shell saw her lead global strategies in e-mobility and hydrogen, culminating in her current role heading battery swapping, simplifying electrification choices for vehicles. Kasturi is a prolific thought leader and keynote speaker, advocating for e-mobility and safe mobility options. She mentors e-mobility startups in developing markets, exemplifying her commitment to fostering sustainability and inclusivity in the industry. Today, she is going to speak on batteries at the heart of e-mobility. I would request I would request Kasturi to take it over from here.
Thank you, Santosh. Thanks for the kind introduction. Hope you can hear and see me all right.
Yeah, we can hear you. Yeah,
Okay, great, great. And I can share my screen for a few slides as well, right?
yeah, you can do that. Yeah.
All right, great. So let me bring up a few slides that will help us talk through this. But while I do that, I want to commend what Santosh is and his team is doing. Not just with this group today, just amazing hearing Shipra just now on cutting edge technology in e-mobility, but also through many other initiatives in clean energy that are being taken up by the team. I think it's much needed and is being very beautifully done. So I'm really happy to be here talking about this and having to discuss these challenges, opportunities, all that e-mobility brings amongst us. Okay, so let's get into it. I wanted to bring us to the core, or how I see it as the beating heart of e-mobility, which is batteries. It powers the vehicles as much as fuels in our traditional world, ongoing world, fuel the petrol and diesel vehicles, right? So we are really just replacing one form of fuel to another is how at least we see it as an energy company. And when it comes to the why we are all doing all of this, and we've spoken quite passionately about it across speakers today, I just want to quickly underline that the why of it is highly diverse, highly variant when it comes to different markets, different customer segments, different types of users. And we see that across Shell's customers, coming from fleets, big and small, to individual B2C customers, to different types of B2B2C platforms as well, like ride sharing these days. And it's all sitting on a highly variable level of maturity when it comes to the infrastructure as well. So we are looking at absolutely bustling flyovers, smooth traffic, and on one end we are talking about busy two-wheelers going through the streets, and all of this is happening at a tremendous pace. And in India, of course, we see uh, humongous potential as we see the two-wheelers and three-wheelers just uh, dominating the electrification in that sense, and four-wheelers picking up. It definitely in major cities, they're becoming a common conversation at dealerships. And all of this basically means we need to be very conscious about how we see batteries that are fueling them, running them, driving them. And from Shell's point of view, we've always been an energy provider, infrastructure provider that makes these vehicles move. And we play the same role when it comes to electric mobility. I'll share briefly in a bit about what we are doing in electric mobility and all the different areas where we look for partnerships, where we are building capabilities, and quite welcome thoughts and ideas on how we can do this more. So batteries specifically, we don't manufacture batteries ourselves, but we have a tremendous amount of effort put on understanding batteries, on researching batteries, especially on battery degradation, understanding battery life cycles, because they touch multiple aspects of our businesses. This is not just e-mobility. There is big renewables business that we have globally. And batteries, of course, are becoming a big solution to intermittency there. And stationary storage is a beautiful link between what goes into vehicles and can be repurposed to, to support stationary grids. Now, in terms of the type of activities, we look across the battery life cycle, different capabilities. As a theme, battery circularity and battery storage are superbly important for us. So we have quite a few partnerships and investments in battery recycling and understanding the crossover as to what happens at the end of the first life, right? We talk about this a lot in our community of EV practitioners, EV enthusiasts, that there's a tremendous amount of rare earth minerals going into batteries, highly precious raw materials going into batteries, and not just from a sustainability point of view, but also commercially. We need to figure out what happens after the first life. How do we associate concrete value to what we do with it in the second life, whether we are reusing them for, let's say, as inverter batteries, or we are putting them to support the grid for renewables for peak times, or we are basically recycling them to just extract the raw material back again for the next use. So quite a few problem statements to be solved there, including what's the best technology, what's most commercially viable, but also how do we predictably say this is the dollar amount or rupee amount that we can associate with second life. So that's a big focus for us. It cuts across technology and business models. So Circonomics here, for example, is one partner that we have. They look at marketplace uh, concept for second life batteries. So the vision there is that you should be able to, as a consumer, at the end of your first life, have a way of selling it on a marketplace or even selling it back to your automotive OEM company, and they should be able to utilize these marketplaces to get value out of it. So that's just one aspect of it. On top of it, there is some deep work involved in understanding the battery chemistries, the electrolytes, just being a smarter user and buyer of battery technology as an energy company. And the last one, which is thermal fluids here, is a very interesting example of how the same use cases have transferred from the traditional fossil fuel world to the EV world, and how movement stays the same, but we're transforming the how so tremendously. So thermal fluids are basically coolants in a very simple way, if we had to talk about it. And what we are trying to do here is when we have these batteries operating and supporting very high energy use cases, we have think about data centers, right? We talk about artificial intelligence quite a lot. Almost every other conversation these days is about that. There is tremendous amount of computing power and a lot of energy that is consumed in that process, which generates a lot of heat. And this heat needs to be managed both in terms of the efficiency of the computers and the batteries that are used for it, but also from a safety point. And that's where these thermal fluids come. And we sell a lot of these thermal fluids to data center customers, to technology customers like Microsoft, Amazon, and such. So these are all the different areas that I hope just give a flavor of what goes on around batteries and around e-mobility while we see things move around us. And bringing it back to movement and mobility, right? And this is one of the things that I picked up early on when I joined Shell was how do you take these capabilities that we as a society have built around movement and mobility and take them to shape what we are trying to do with cleaner choices. It is about very similar fundamentals. If you're setting up an EV charger, you're talking about the same demand and supply dynamics. You're talking about the same point of view in terms of how do you pick the right locations, how do you enable easy customer journeys. So how the idea is to take the same fundamentals and capabilities to a different world, a different technology. And we hope to do that with the extensive network that we have. We have around 47,000 um, Shell branded locations where we sell traditional fuels as well as EV charging. And if it's any indication of how Shell as well as this industry is transforming, it is to compare that number with the number of charge points. So the number of charge points of 55,000 are the ones that Shell already has in place in terms of public charge points globally today, including our own stations, destination locations, and on street. And it's growing super fast. This number was around 27,000 last year, early last year, and it's gotten to 54K at the end of 2023. So this year, 55,000 already. So you can see that growth in infrastructure mirroring the growth in vehicle sales. And how it all comes together is overall as an energy system, it's highly connected, even more so now than before, if we look at it. And for us, it's this integration, it's this interconnection that calls for a complicated but highly important backbone for the energy consumption that we do, not just from a mobility point of view, but also from the point of view of energy that we consume at homes and at offices, at different locations for moving, for consumption, for creating. And a big part of the value that we generate comes from being able to stitch it all together. So we generate our own renewable power. We integrate it with EV charging in a lot of markets. We also convert it into fleet solutions that we help try electrify. And as I'm sure a lot of us would appreciate, it's not a one-stop abrupt conversion here. So a lot of times we are sitting with our customers, fleet customers, and saying, how do we transition a fleet of hundreds and thousands of vehicles from traditional fuels to EVs? And it happens phase by phase. It happens with a lot of conscious thought because it's highly operational. We cannot afford to disrupt the supply chains, and that's a big part of the energy transition uh, journey that we take, not just ourselves but with our customers. And on top of that, cutting edge technologies, we spoke about, we heard Shipra just before me, and that was an excellent example of deep tech that we were talking about. We, we look at some other aspects as well when it comes to digital capabilities for e-mobility and energy management. And that becomes a way for us to stitch it all together. The utopia of this, I think, for the whole industry is to be able to optimize at that level where every electron is being utilized in the best possible way. And that's basically how it all comes together. If there are a few takeaways that I would want to leave you with is there are many components to this puzzle when it comes to the energy systems. But even with e-mobility, there are so many opportunities and things to solve for, which should keep us excited and give us a reason to get up and do what we do. But it comes from a lot of people working on different things deeply, and partnerships and being able to work together is a big part of that. So I hope it sparks some ideas and some thoughts on how we can engage in this together. We can talk about it, potentially partner as well. And I'll leave it at that and maybe open up for questions, if any thoughts, comments.
So if there are any questions to Kasturi, then participants can raise their hand and ask the question.
Okay, thank you. So, Ms. Kasturi, it was very interesting and elaborative presentation. Thanks for that, and congratulations that Shell is involved in so many diverse value chain across the EV mobility or the, let's say, battery value chain. Just a question to understand where the Indian market, I mean, in reference with the Indian market, the Shell is doing. So maybe can you elaborate in a couple of sentences? What is the activity locally being done by the Shell?
Sure. Thank you. Thank you for that comment and question. Indeed, India is a big growth market for us. So there are many different businesses we have in India. We have an LNG business, we have a mobility business. So you should see a lot of our petrol stations if you travel through the southern states or the western states. That's where most of our network is placed. So we have that. On top of that, we also made a major acquisition some time back called Spring Energy, which is been the largest investment in renewables that Shell made across the globe, and it was in India. So
Sorry to
from that,
interrupt, Kasturi.
yes.
Sorry to interrupt. I wanted to know more specifically related to the EV battery.
Okay, okay. All right, all right. So from an EV battery point of view, we haven't made any investments in India specifically. They are in other countries, but we do have a presence in e-mobility. So we are growing our EV charging business as we speak. You'll find quite a few cities which have Shell EV chargers already, both at our petrol stations as well as destination locations in office complexes, for example. Bangalore, Pune, for example, have quite a few. And on top of that, we did make investments in venture capital investments in companies in this space. For example, Rapido, for example, Static. So we have uh, quite closely engaged with the startup community in that sense in India. But yeah, our focus mostly has been on EV charging for four-wheelers.
Thank you, Kasturi. Maybe just one last question. In terms of chemistry, what do you think? I mean, on your personal note, what do you think? Whether it's maybe NM, say LFP, or what you think should work for Indian market particularly?
That's a great question. I would say I would be crystal balling if I picked one over another. But there is, of course, existing potential of what we see. We see a lot of LFP, NMC going around. But I do see some of the emerging ones like solid state batteries being an interesting one. We are looking at it quite closely. I'm quite optimistic that we'll see some disruption in chemistries as well, but that's the extent of the bet I can basically place at this point. It's yeah, yeah.
Okay, thanks, Kasturi. Thank you very much.
Thanks a lot, Kasturi, for this wonderful presentation.
Most welcome. Thanks for having me.
So we had one more speaker with us actually. He was Mr. Devi Prasad Dash, and he's an executive director at India Energy Storage Alliance, the association that is supporting us. But due to some urgent uh, meetings, he was not able to join this particular session. And hopefully, the association has been supporting us in our initiatives, and in maybe quite in the next session, he will be able to join us. With this, I would like to extend our vote of thanks to all actually. And before we end, actually, any of the participants still wants to ask any questions to our participants, just any of our present speakers that were there, they can please go ahead and ask. Actually, again, Mr. Ehsan is there. You can go ahead and ask the question, Mr. Ehsan.
So thank you, Santosh. Thank you very much from your team for organizing this event. It was indeed interesting. Although I missed some of the part, and I have to leave in a couple of minutes for my next meeting. Just one request, maybe if you are organizing something on the component level, the battery component level, it will be of great interest because a lot of industries, okay, from the value chain perspective, okay, there are different segments, but I'm talking about the, let's say, the CAM manufacturers, precursors, or the ARM manufacturers, or even electrolyte. We are seeing a lot of activity nowadays in the Indian sphere, and they are not only for the domestic market, they are targeting heavily onto the very competitive markets like China and Korea, etc. So it will be a great if you can organize something around it. So thank you very much. I may have to leave in a couple of minutes.
Yeah, definitely, Mr. Hassan, we will look at it actually. How can we incorporate the suggestions that you have given, and let us see how we can do some event, or maybe we can include those sessions in our regular other uh, scheduled business meets that we have planned for this year actually. So thanks a lot for this suggestion, and thanks for joining. Thanks a lot for to all actually. On behalf of Smart Energy Magazine, I extend our heartfelt gratitude to all the distinguished speakers, sponsors, participants, and attendees for making the PowerUp EV virtual business meet on EV technology, battery manufacturing, and charging infrastructure a resounding success. We are deeply honored to have had the opportunity to host such a distinguished group of experts who shared their invaluable insights and experiences. Your contribution have enriched our understanding of the evolving landscape of electric vehicle and sustainable mobility. We would also like to express our gratitude to our sponsors for their unwavering support and commitment to promoting innovation in the electric vehicle industry. Your contributions have been instrumental in making this event possible. I would like to mention here the sponsor for today's session, Hyperion Chargers, EV FinServe, Comsol, and Gantner Instruments. To all the participants and attendees, thank you for your active participation and engagement throughout the event. Your enthusiasm and passion for sustainable technology are truly inspiring. As we conclude this virtual business meet, let us remember the critical role that electric vehicles play in mitigating climate change, reducing air pollution, and achieving energy independence. The transition to electric vehicle is not just a choice, it is a necessity for a cleaner, greener future. Let us carry forward the knowledge and ideas exchanged here today to drive positive change in the field of electric vehicles and create a more sustainable future for all. Thank you once again to everyone who has been a part of this event. We look forward to your continued support and participation in the future endeavors. Thank you. I would like to mention here that this entire session will be available on YouTube channel. So you can subscribe to the YouTube channel of Smart Energy Magazine to get regular updates from the industry. Even you can follow us on LinkedIn to get regular updates from the clean energy and e-mobility industry. So thanks a lot. Thank you very much. I once again thanks, and we will update you with our next session very soon. Thank you for joining on this virtual business meet.